All right, here we go. 9.1 sequences and series. Go ahead and copy this down. So a sequence is a list of numbers. I'll give you any list of numbers separated by commas. For a famous example is this one, 1, 1, 2, 3, 5, 8. This is actually what's called the Fibonacci. You don't have to write this down, but it's called the Fibonacci sequence. It's made by taking the first two terms, and every number is called a term. Taking the first two terms, adding them to get the next one. Then you repeat the process with these two terms. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Very famous sequence in math. Now, there's a special kind of sequence, list of numbers, called an arithmetic sequence. Don't say arithmetic. It's an arithmetic sequence. And that's a list of numbers where you add or subtract the same number to get the next number. Let's go ahead and look at this one. So our sequence is 10, 7, 4, 1, negative 2, and the pattern continues. That's what the dot, dot, dot means. Well, what does it take to get from 10 to 7 if you're adding or subtracting? Well, to get from here to here, it takes you to minus 3. And if you notice, that's true every time. 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is negative 2. So what you say is this arithmetic sequence, you say that d equals negative 3. And we'll see more about the variable d in a second. But that's how you know it's an arithmetic sequence, because you added or subtracted a number, the same number, every time. Let's go ahead and look at some more examples here. Now this, go ahead and copy this down. So we have the nth term of an arithmetic sequence. It has a formula. It says a sub n, so that's a subscript n, equals a sub 1 plus d times n minus 1. And I'll tell you what all these stand for. So a sub 1 is just your first term, whatever the first number is in your sequence. Like for this example, our first term is 5. So a sub 1 equals 5. A sub 2 would equal 6.5. You could actually label these all with like a sub notation. A sub 1 is 5, a sub 2 is 6.5, a sub 3 is 8, and so on. For our purposes, we'll probably just need a sub 1. Now d, remember how we just talked about what d is? So how we said d is equal to negative 3? Well, d is what's called your common difference, and that's the number that you have to add or subtract to get every number next on the list. N is your number of terms, and a sub n is the nth term. And we'll talk about what that means in a second. But what we're going to do is, this example says, find the 48th term of the sequence. Well, it should actually say arithmetic sequence. We're assuming it's arithmetic, meaning that you can add or subtract some number. Well, if you look here, what does it take to get from 5 to 6.5? Well, you would have to add 1.5. Is that true here? Yes. 6.5 plus 1.5 is 8. Is that true from here to here? Yes. So it looks like our d value is 1.5. Now you might be thinking, why do I need a formula to find the 48th term, the 48th number in this list? Can't I just keep adding 1.5? Well, you could, but we need to practice the formula. That's the point of doing this section. So again, you could add 1.5 that many times to find the 48th number in the list, but we want to use that formula. Let's go ahead and identify some other things. A sub 1 is your first term. You said earlier that a sub 1 in this case will be the number 5. All right, if you're trying to find the 48th term, that means that in this problem, n is going to equal 48. Okay, so we have 3 things we can plug in, and we don't know what the nth term is. That's what we're going to try to find. So our goal is to find a sub n. You're going to see it's very easy, because all it is you're plugging into the formula. So I don't know what a sub n is, so I don't know that part of the formula, but I know that a sub 1 is 5. Bring down the plus sign. D is 1.5. And then I have n minus 1. Now, if you can do a little mental math here, you know that n minus 1, in this case, would be 48 minus 1, which is what number? That'd be 47. All right, this looks very simple. All you have to do now is just calculate what this is. Remember to follow your order of operations. Don't do 5 plus 1.5. You got to do 1.5 times 47 first. Then you're going to add 5 to that, and your decimal is 75.5. And so actually using the formula is probably a lot faster once you know the formula, than adding 1.5 that many times. Or another way I could justify using the formula is, what if I asked for the 500th term? Would you rather add 1.5 or use the formula? If you're going to try to find the 500th term, you'd rather use the formula. Alright, so that's pretty easy. Let's go on to the next one. Now, we just saw what a sequence is, but the title of this is Sequences in Series. So, go ahead and copy this down. All a series is you take a sequence and you just add all the numbers up in the sequence. So it's a sum of the sequence. For an arithmetic series, here's the formula. It says S sub n equals n over 2 times a sub 1 plus a sub n. So I tell you what these mean. A sub n means the sum of the first n terms. N is the number of terms, and a sub 1 is your first term, a sub n is your last term. So this example says, verify the series is arithmetic, meaning what that means is we're going to find D. Then we're going to find the sum using the formula. Again, I get it. You could add these up with your calculator. It's not a hard thing. Even an elementary school can do that. But the point is, we need to practice using the formula. So let's go ahead and first verify it's arithmetic. So what does it take to get from here to here? Well, it looks like it's plus 2. And is that true every time? You can probably tell that it is true. So by verifying, we're going to say that D equals 2. That's the verification step. Because you can add 2 every time. That's how you know. Now we're going to find the sum. So n is the number of terms. If we count this up, 1, 2, 3, 4, 5, 6, 7, 8. There's 9 terms. A sub 1 is your first term, which is, in this case, 1. A sub n is your last term, which is 17. Plug into the formula. So S sub n becomes S sub 9. So that's just notation. It's just saying add the 9 terms up. N over 2. That becomes 9 over 2. On the inside, we have the first term plus the last term. That's 1 plus 17. Okay, 1 plus 17 on the inside. Let's do order operations. That becomes 18. And then we just do 9 divided by 2, which is 4.5 times 18. Can't type today. So that's 81. So if you were to add these numbers up, you would get 81. You can verify by doing it the long way. Again, the point is to practice the formula. All right, so we saw arithmetic sequences in series. There's also what's called geometric sequences in series. So a geometric sequence is a list of numbers where you multiply or divide by the same number to get the next number. So, arithmetic was adding and subtracting for your list. This is multiplying and dividing. So this example says you have 1, 2, 4, 8, 16, 32. So to get from one number to the next, it looks like you have to multiply by 2 every time. So that's the process here. Now, you know how we said arithmetic sequences had a common difference, and we said the letter D was a common difference? For geometric sequences, you're going to use the letter R to tell what this number is. In this case, R equals 2. That's what you have to multiply by every time to get the next number. Let's look at this one. Now this one, how do you get from 100 to 10 by multiplying or dividing? Well, you have to divide by 10 every time. And even 1 divided by 10 is 1 over 10, and so on. So in this case, my R is 1/10. Or you could say R equals 0.1. And how do I get 0.1? I did 1 divided by 10. And that's 0.1. Alright, so now, to find the nth term of a geometric sequence, any term of the list that you want, here's the formula. It's a sub n equals a sub 1 times r to the power of n minus 1. And again, r is what's called your common ratio. So D is common difference, that's for arithmetic. R is for common ratio for geometric sequences. Alright, this says find the 20th term of the geometric sequence. So here I see a list 1, 3, 9, 27, ... Well, it looks like to get from one number to the next, I have to multiply by 3 every time. So that means my R value is 3. Alright, if I look at my formula, I got R now. I need to find N. Well, N, they tell me I need to find the 20th term, so N equals 20. A sub 1 is your first term, which we found to be 1. Alright, it's as simple as plugging into the formula. So I don't know what A sub N is, that's what I'm trying to find out. A sub 1 is 1 times, put your R value in parentheses, 3 And then to the power of n minus 1, well, if n is 20, 20 minus 1 is 19. Now, the 1's not going to really matter, so I can just kind of, I don't need that. Maybe you shouldn't cross it out, but really what we're just calculating is 3 to the power 19. So I just plug it in. Now I do get a big number. So this is the 20th term. If I was to extend this list out to the 20th term, I would find this number in the 20th place. All right, one last thing I got to show you is how to find a series. What if you're adding up one of those sequences? So here's the formula for geometric series. It's S sub n equals a sub 1 times parentheses 1 minus r to the power of n, that's r to the power of n, all over 1 minus r. So by now, I think we know what all these symbols mean. S sub n means to find the sum. That's your first term. R is your common ratio. Again, common ratio. And n is the number of terms. All right, so let's just go ahead and find everything. It says verify the sum is geometric, then find the sum using the formula. Again, we can plug this into our calculator. That's easy, but we need to practice the formula. So let's start with a sub 1. That's 20,000. R. So what does it take to get from here to here? Now, if you're wondering how to get from here to here, what you do is you take the second term, 4,000, and divide it by 20,000. And actually, let's go ahead and just so for your reference, let's go ahead and say this is what we did. We did 4,000 divided by 20,000. And we found it to be 0.2. So that's how you find R. In case you're not totally sure how to find R, you take the second term divided by the first term. How many terms are there? 1, 2, 3, 4, 5, 6, 7. All right, so now it's just a matter of plugging into the formula. So S sub 7 equals 20,000. That's your A1. Parentheses 1 minus R to the N. So that's going to be 0.2 to the power of 7. All over 1 minus R. All right, now follow your order of operations. Let's go ahead and do, we can do this. 1 minus 0.2 to the power of 7. We can do that right away. So we get that number. 9999872. Let's also figure out what's 1 minus 0.2. That's 0.8. So now I'm going to do 20,000 times 0.9999872. I get that divided by 0.8. And that's 24,999.68. All right, so and you can verify that if you wanted to add all those up, and you should get this number anyway. I'm not going to do that, but you can verify. All right, so we're done. I do have a math picture pun. And actually, we'll call it a riddle. And this is the name of a famous movie represented with a math picture. If you can figure this out, let me know. I'd be interested to see if you guys can figure out what movie does this represent. Name of a movie. All right, there you go.